Hello guys and welcome back to my video. So in this video I'm going to show you how to use Seaborn. So Seaborn is a data science library that is used for data visualization. So the first step that we are going to do is we are going to import NumPy as NP, Pandas as PD. We are going to import Seaborn as SNS. We are going to import Matplotlib as Seaborn runs on top of Matplotlib. So the other thing that we are going to do is we are going to load our dataset into Pandas. So if you don't know what Pandas is, make sure you watch my previous video on Pandas. So we provide the path to our FIFA dataset, and then we read the dataset using the read CSV function from Pandas. And then the index column, we want it to start from 0. So let's run our, and then we want to display the first five items in our dataset. We use the .head function. And then we want to display the info in our dataset. As you can see, we have the ID, name, age, photo, nationality, flag. So we want to check the FIFA 19 body type. As you can see, we have normal, we have 10,595, lean, stocky, and then different players, right? So the first thing that we are going to do is we are going to be exploring our age variable using the dist plot. So the dist plot function flexibly plots a univariate distribution of observation. So let's plot a dist plot. So and then we provide our dataset, which is FIFA 19, and then we want to use the age variable. We want to plot the distribution of the age variable. So to use the dist plot, we say sns.distplot. Remember that we imported our Seaborn as sns.distplot. We then provide our dataset, which is our age variable, and then the bins, which is goes to 10. As you can see, now we have our dataset. As you can see from this dataset, what you can deduct from this dataset is this dataset is positively skewed. As you can see, the bar graphs are skewed to the left or are skewed to the positive side. So if you do not know what is skewness, I advise you to watch my video on skewness. So the other thing that we can do is we can also plot this dist plot vertically. So to do that, I'll just copy, and then I'm going to pass in the vertical variable, which is equal to true. As you can see, now our graph is now being displayed vertically. So the next thing that we are going to talk about is kernel density plots. So kernel density plots, they are useful for plotting the shape of the distribution. So let's also use the edge variable to plot our kernel density plots. We want our figure size 8 by 6. Use is we use the KDE plot function. We then provide the dataset. As you can see, the KDE shows the skewness of our data. As you can see, it's positively skewed. We had also used this KDE on top of here when we used our dist plot. As you can see, our dataset is positively skewed. The other thing that we can do, we can also shed the area under our KDE plot. To do that, we just pass in the shade variable, and then we pass in the color variable, which is we want the shade to be red. So it should be capital letter T. You can also provide yellow. So the next thing that we are going to look at, histograms. So a histogram represents the distribution of data by forming bins along the range of data, then drawing bars to show the number of observations that fall in each bin. So we use the hist function. So f is equals to ax, which is equals to plt dot subplots. We then provide our figure size. Want to be in 8 by 6. Provide the age variable. We then use the dist function. We then provide our data set. We can set our kernel density plot to be equal to false. Drag is equals to true. And bins is equals to 10. You can just play along with the parameters to understand how it works. As you can see, guys, the histogram plus the distribution. As you can see, from let's say from the age of 16 up to the age of maybe 18, there are 1,000 people. From the age of 20 up to the age of, let's say, 21 or 22, there are about 3,500 people, as you can see from the histogram itself. So if we pass in the KDE equals to true, it will draw a kernel density plot on top of the histogram. As you can see, we now have a kernel density plot showing also the skewness of our data. So we can also use the dist. We can also use the dist plot function to plot a KDE directly. So to do that, we simply change here, simply passing the hist parameter, and then we pass in the false, the Boolean type false. As you can see, now we now have a KDE plot. So now what we are going to do, let's explore the preferred food dataset in preferred food variable in our dataset. So guys, I'm not going to explain about pandas. So if you want to know more about pandas, I advise you that you watch my previous. It's supposed to be funny. As you can see, we have two unique preferred food. That's obviously left and right. So now we want to count the number of counts in each category. as you can see, we have more people that are right-footed and less people that are left-footed. So what we are going to do is we are going to visualize this categorical data using a count plot. So a count plot shows the counts of observation in each categorical using pins. So in this case, it's going to show us the counts of the left-footed people and right-footed people, right? So to do that, let's do it in pandas, in using Seaborn. Sorry. So our x variable, we are going to provide the preferred food variable. And then for the data, we are going to just pass in the 119 data frame. And then our color, we can use red actually. And then we just print pot.show. So now, as you can see, it now returns the counts for the people who are right-footed and count for the people who are left-footed. So using the count plot, we can also show value counts for two categorical variables. So to do that, what I'm just going to do is I'm just going to copy this code above, and I'm just going to paste it in here, and then I'm going to change. I'm just going to put another variable called foo, which is going to be our second category, which is a real face. We want from preferred food, we want people with real faces. I'm sorry, I left out a corner. Now, as you can see, we now have real face. So now we have from real face. From the real face, you can see that about less than 1,000 people are right-footed, and then about 12,000 who don't have real faces are right-footed. So now I'm just going to. We can also draw this this graph vertically. So I'm just going to copy this, and I'm just going to paste it. And then instead of x, I'm just going to provide y is equals to preferred food. And then I'm going to delete this variable. As you can see now, we now have a vertical graph. So, and then the last we are going to talk about is a cat plot. So we can use a cat plot to plot categorical scatter plots. So to do that, we are going to just say this goes to ns dot cat plot x is equals to fed kind. We are just going to pass in count, then palette. And then the data we are just going to provide the FIFA 19 data. As you can see, now we have a cat plot. As you can see, now we have a cat plot. So thanks for watching, guys. If you find the video useful, please make sure you click the subscribe button, the like button, and make sure you share this video so that so that this video can reach as many people as possible.